All right, man, shoot, what's the question?
Okay. We have the main function, right?
Hmm.
That you gave us on at the end of class, define
Yep,
main, hello world, and the if statement and all that. Now
yep,
the okay, that's an explicit definition of a function, right?
yes.
Okay. Now I went to ChatGPT and I says, give me a function that will give me a script that will write a Fibonacci number based on a input.
Okay,
It did a masterful job, right?
sure.
Okay. But I don't see a main function. I see
Uh,
the if statement that refers to the main, but I don't see the main function defined in there anywhere.
yeah, so main is just a naming convention. You can call it whatever you want to. Like that's just again as a really standard tutorial naming of a function, we use main, but there's no reason that it has to be the word main. It could be literally anything that you want. So whatever function ChatGPT wrote for you, it was probably explicitly named the thing that you're trying to get that function to do. That's kind of generally the naming, again, style and convention. You name a function kind of what it does without getting too long of a name. But I'm assuming that if you said that you wanted it to do what again, what did you say you wanted the function to be able to do?
Fibonacci series.
Fibonacci. It was probably called something Fibonacci, some permutation of Fibonacci, right?
Well, actually, I tried Fibonacci in the if statement,
Mm-hmm.
and it tried and didn't work. It
Okay.
gave me some kind of an error message. So I just switched it to main for, lack of really know what to do with it, and it worked fine.
Okay. So there's probably it was probably that you took what I'm assuming again is that ChatGPT probably wrote a function called Fibonacci, and then you took the internal parts of that function and put it in your main function. And so then it works when you call main because that's the name of the function that you had. If you do you want to share your screen? Do you have it open? You can share. You can
Yeah,
show. Because
yeah,
I'm listening to you. I'm assuming what happened was that you didn't take the name that ChatGPT gave you, and you kept the name main, which is fine. It's just that that's what you got to refer to it as, right? There's no reason that we call it main outside of convention. Like again, for tutorial purposes to show you that it's like the main function, but you could
okay,
call it whatever you like, right?
okay.
So
So no, that should be. I'm gonna minimize you here.
sure,
Okay.
do what you need. You know how to share your screen through Zoom?
I think I forgot.
There's a right in the middle. There's a like a greenish up arrow thing. It says
Oh
share
yeah, okay,
underneath it.
okay, I got it.
Click on that, and then it'll tell you to like choose which part you want to share.
Yeah, I haven't run a Zoom meeting for a while.
Yeah.
No, I'm just seeing a big picture of.
So you have to choose which window you want to share after you click share. It'll
Okay,
it'll like give you a little dialog box that says choose. You have to click the picture of the window you want to share. And it should be your whatever you have your code in, and then it should pop up on the screen and we can have a look at it. Which I'm assuming if you're doing a Python anywhere, which I know you are, should be in the browser, right?
well, actually, right. I'm in. Yeah, let me go to the browser because I'm trying to do it from ChatGPT, and that's clearly wrong.
Oh yeah,
Uh,
it can't run from ChatGPT.
okay, that's why.
That'll do it too. Yeah, but it'll be a lot easier if you could share your screen, then we can kind of see what's up.
Okay,
Maybe walk
yeah.
through it a little bit.
You notice how I'm this mad combination of. Oh, there it is. There it is. Okay, yeah. So I have the Python Anywhere file open.
Hmm.
I don't see a place on there to share that.
Yeah, that would be on Zoom. That's what I'm saying. You have to share your screen on Zoom first, and then share the screen that Python Anywhere is doing its thing on.
Okay.
So however you're watching Zoom, there should be a little share button in the bottom middle.
Oh crap. Okay. So I'm back with you and me talking here, right? That screen.
What's up?
Okay.
Yep. And the bottom of that screen, there should be a share button. Big
Yeah,
little.
there's a share.
Yep. Click on that thing, and it'll pop up with a dialog that tells you it tells you to choose which screen you want to share.
Oh, okay, I got it. And then share.
Mhm. Boom. Now it's coming through. All
Okay.
right, cool. So there we go. So definitely, so you got a function called Fibonacci series upward limit. So you set the number that you want to reach.
Yeah.
And then it says if name equals main, you're calling Fibonacci series 22. Okay, cool. Right. Yeah, that all looks good. So what's the problem?
Okay. The problem is, see down here, line 14,
Hmm.
where it addresses main,
Yep.
but main is not defined anywhere in this. So
Ah, okay. Line 14. All right. Yeah.
the one I defined is Fibonacci series in line one, right?
Sure.
That's what I tried first to put in there,
Okay.
but it
For
didn't work.
everybody, for everybody that's just joining, Michael had a question real quick. This is what kind of why we jump on early. So I'm going to see if I can answer that question real fast, but it might be pertinent to you too. So Michael, to understand your question, I want to make sure I got it clear. You're looking at line 14 of your code where it says if underscore underscore name underscore underscore is equal to main, right? That's the line you're looking at?
That's the one.
Yeah. Okay. So that is referencing nothing that's written in this file. So you don't define either of those terms. That's a standard. The name equaling main is a standard convention in Python. That's the entry point to your application. It allows it to be run as a module from somewhere else. So
Oh,
that
okay.
that underscore underscore name is a reserved variable that's written into Python and it's always in there. And the underscore underscore main, that's what is happening in the background. Like when you do Python 3 space main.py from the the console, what it does is it goes through and reads, and we'll go back over this in a second. It's actually really good that you asked this question. We'll go back over this in a review in a second, but it reads through the file, and when it gets to that section, it checks to see if that name thing, if that variable is equal to main, and it will be if your thing was called as a module from outside of this script, right? So if
Okay.
so that's what that's doing. You don't have to define name, and you don't have to write main anywhere. So exactly what you did here is why it works. The Fibonacci underscore series, that's the function that you defined on line one. And that's exactly what you should call inside of that block of code on line 14 and 15.
I,
Because just
I swear, what I tried to put, let me, I'll fiddle with it some more again, but I swear when I put the Fibonacci series in where main is right now, it didn't
it didn't
work.
work. Okay. Yeah,
It
if you could
didn't.
replicate that, yeah, if you could replicate that, that would be awesome. I mean, I'd like to, not awesome that you saw the bug, but it'd be good to show them what that is. But we're actually
Okay.
going to talk more about that structure and make sure that it's clear. But did I kind of answer your question for now?
Yeah, definitely.
Cool. Cool. I am going to take over the screen share then,
Okay.
which is done. And hello to everybody that was joining. Right now, we're right at 1800. Thank you, everybody, for joining a few minutes early. We're on time. I appreciate it. I was just talking with Michael. He joined a little bit early and had a question about the code that he wrote in his file. And it's, if you didn't catch the full answer that I gave, we're going to go back over actually that same content when we get to our review. So it's really pertinent question about the if name equals main construction that we did at the end of the class on Thursday. So let's dive in today. Everybody, thank you. Welcome back. We're in week 2. And we are going to roll right into some stuff today. We're on day 3. We're going to do basic algorithmic problem solving today. We're going to start by wrapping up a few of the control structures that we talked about. We'll go through a little review real fast to make sure we refresh everybody's memory on what those are. But we need to kind of hammer through those a little bit. And then there's one more data type that we need to get through. That's the coolest thing in Python, but it takes some time. So I didn't want to try to jam it into the last class. And then we're going to end with sort of an assignment to take away and some problems to work on to do some algorithm, writing your own algorithms and solving problems with them to get some practice. Um, but let's go to a quick review. So we did in our last week. This is only the second week. In the first week, we did a quick explanation of kind of what's happening in a computer when you write in a human language. It boils down to binary. We talked about data in that sense of being stored in bits and bytes. Then we talked about applications and writing them, how you store data in Python in the sense of numbers and strings and things that you write down. So we should have ended on Thursday. If you're following along, you did the pieces up to now. You should have a Python program, an application, very simple in a main.py file that you can run by saying Python 3 main.py. We can actually switch over to that, have a look. So in our bash console, just over on Python Anywhere, and just in our home directory, so you see the little tilde in the time next to the $sign. And if we just type in Python 3 main.py, I'm using tab complete to make sure that I still have that file in there. When I hit enter, it should print out hello world. So this is where we ended up on Thursday. We have a basic application. And I'm going to go over into our files over here on the right, it's the hamburger menu, because we're going to spend a lot more time in the file, or I guess text editor that's built into Python Anywhere. So we're going to get to that with files. I'm going to open it in a new tab because we're going to come back to this terminal at some point. But to refresh your memory on what's in the main.py file, very simple code. So this was the piece that Michael Collins was asking about. And this is the piece that we ended with. It's the entry point into our app. And I want to make sure that we're really clear on what this is and what it's doing, and see if we had any questions on anything up to this point before we dive further and finish off what we needed to today. Anybody have any questions? Did anybody? Michael was actually just showing he ran a he wrote something to do a Fibonacci to return Fibonacci sequences, or a Fibonacci sequence with a maximum limit. Did anybody else go and try writing some code or using ChatGPT to write an application and run something more than printing back hello world? No. I can see Steven shaking his head no, which is also good to admit. No, that's okay. It's okay if you didn't. I'm just checking to see if anyone else did.
I got kind of lost at the end of the last class. I guess I should have stuck around and asked some more questions, but it wasn't until I saw the review that I saw how you went about it. So I'll do it between now and Thursday.
Okay. Yeah, no, if you're stuck somewhere, then definitely, now's the time to kind of raise your hand and say, I'm stuck. I couldn't get past whatever the case may be. But so just a real quick recap of what Michael asked. It was a good question, and it was about this piece right here where we did end. So I want to make sure that we're clear on this. We're going to use it again, this convention, this statement, this little piece right here. And actually, we can actually wrap up a review and kind of move into the next thing. This is the next topic we want to talk about. So one of the things that we ended with last time was this concept of control structures. So if you remember, we had sequential control structure, which is reading the file. The computer reads the file top to bottom, left to right. So it starts up here, line 1, very space 1. It reads this definition of the function that we made and what it does. And then it reads down to line 4. And this piece right here is called a conditional control structure. So what it does is it checks for a condition. So it starts with if, which is a reserved words. All the words in blue in here in our text editor are reserved in Python, so you can't use those for other purposes. And then this condition that it is checking is a standard statement that represents what's called the entry point to a Python application. So this 2 underscores, and there are 2 underscores here, that with no space in between them. I put a space so you can see if there's 2 underscores in the name. Those underscores don't mean anything special for Python. That's a human readable kind of indication that this is a special variable, but it is nothing more than a variable. So it's just a named thing in memory that Python has kind of reserved. And it can be a number of things. If it is main, that's what this is checking to see if that thing is main, and it will be main when you run this command the way we did. We're in Python main.py. That's not because this file is called main. I want to make sure that no one's confusing the two of those. This file could be called anything. We could call this file hello. We could call this file world. It doesn't matter. The fact that this is main is being dictated by us running this construction in its entirety. So the fact that we're running the file from the outside of the file and we're not running it from somewhere else, we're running a specific thing. This construction is what lets us do that. So is everyone fairly clear on that as a concept? Fairly clear as.
So if you renamed like line 1, you rename it Deaf Frog or something like that, right?
Yeah, sure. Let's call it hello.
Yeah, okay.
All right.
And then that would be hello, right?
Okay. Yeah, we have
That's
to change this to
right.
hello. Yeah, because then we have to call that function.
Okay.
And then what else do we need to change? Do we need to change anything else? This is in our main.py file.
I'm thinking you don't, because main is a reserved word, right? In line 4.
Yep, it is. So if we save this, I'm gonna save it, and I'll just run it out here again by pressing up and recalling the last thing from our history and hit enter. It runs exactly the same. So there's no change
Okay.
at all.
Okay.
No change. We can do the same thing if we rename this file to something else and make it not main, right? So we can just do that real quick. This command is technically how you move things around, but it's also a way to rename stuff. So we do source and then destination, like, make it hello.py. And then to show you that that's what it is. To lslh.
Okay.
So then you can see that it's called something else. Oh, sorry, get this out the way. Too many. All right. Now, if I want to run that command, I'll do Python 3. And now I can't do main because there is no main.py file anymore. There's a hello.py file, and I can run that exactly like we did with the main. So this file being called main is honestly just kind of a convention that when you make an application, there's usually a main file, and people expect it to be there. So, if you make something, you share it around with other people that are used to working in Python, they're gonna be looking for a main file in your application, most likely.
So
But
if you use if oh, go ahead.
no, I was gonna say you don't have to do it that way. It'll function exactly the same. The computer doesn't care. So this is one of those like human readability versus computer readability things that we go back to a lot.
Okay. So people would expect to see that, and they wouldn't be.
Yeah, I'm gonna keep this just in. I'm gonna keep it as main.py just for that same convention reason. But there's no reason the computer needs it to be called main, and it has nothing to do with this main right here. As you saw, I called it when the file was called hello.py, and I didn't make any changes in here because the fact that we're calling it as Python from this construction of Python 3, and then specifying which file. This is what makes that main thing exist.
Okay.
It's being done sort of out of sight. So you never have to set these variables or call this name specifically.
All right. I got it.
Cool. Everybody else pretty clear on that, or we got any other questions about that? I know it's a slightly slippery concept. No? Cool.
It's one of those things you do just because, right?
Not really, just because. I mean, there's a lot to it, and this is worth something. Is if you really aren't catching kind of why this is being done, hopefully the examples we do today will hammer it home a little bit better, because we're going to show how this is used a little bit more and write some of our own files and then import them into here. Okay. But this is also something that's great for ChatGPT. Like, you just copy this, and it's such a standard that anything that you're trying to figure out, you could go to ChatGPT. If I can spell ChatGPT, what is my spelling problem? And then you could just say, like, explain this to me, and just paste it in there and just put the construction in here, and it'll come up with this solid explanation that's like documentation, but a little bit more thorough, or not more thorough, but honed into exactly what you're trying to do. So any of these concepts that you're feeling that you don't have a real solid grasp on, leverage these tools. Look at some of the readings and stuff like that that'll explain these conventional things. So there are sometimes, like, I guess, Michael, to your question, if you don't fully understand how it works, it's less important than understanding that you got to do it, right? So maybe start with, we do it because we do it, but then go back and look at it again until it really sinks in on the why and you kind of understand how it's working a little bit. But yeah, it's not fundamental that you understand every working piece underneath. Think about this like driving your car, right? That something's happening there. You don't have to know all the way down to every little last detail that's happening to drive your car, right? So,
right, okay,
a little bit of just because, but yeah, the biggest things to take from this is that this is the entry point to an application. It's a standard for Python.
Okay.
Cool.
So how do I get into Chat GPT? Is that through the internet or?
Oh yeah, that's just another browser tab. Yeah, that's a open AI tool that's out there that you can use to generate some of the content in here if you wanted to, or write code for you if you like. It's limited, so if you use it a whole lot, they'll stop you at some point for the free one, and they want to try to upsell you. But you can use a free one for.
Listen, of all the toys I've ever played with, that is my all-time favorite.
It's a lot of fun. I usually end up getting into philosophical debates with it, asking like where its parameters are and what what it's allowed to do, what it's not allowed to do, and stuff like that. Yeah, thanks Cody for sharing that webpage. If you didn't see, for anybody that's looking for it, there's the link in the chat from the Zoom channel that Cody just put to Chat GPT if you want to open up and play around with it a little bit. All right, cool. So this construction again we talked about here. This is a standard, but taking a step sort of broader, this is again a control structure. It's called a conditional control structure. And I want to dive a little deeper into this because it's very important for doing algorithmic problem solving and using algorithms to solve problems, which is where we're going with this. And what these are really for is writing your own algorithms. And so what we're going to do is we're going to expand on this conditional control statement to show you the other parts and pieces that could be involved in it. We're going to do these examples inside of other functions just to get in the habit of writing them in functions so that they're not just sort of loose out in different places and invoking in the same way that we have been with this, what was main function now is called hello. We'll write some other functions. We'll call them down here. We're going to follow that pattern just to be used to it over and over again, sort of muscle memory kind of thing. All right. So the first thing we're going to talk about is we're going to finish out conditional control structures. And I'm going to put this in here using what's called a comment in code. So this opening up with a hashtag on a line makes it so that the computer is not going to run this code when I run things. This is for purely human readable notes that you want to put into your code. Don't use too many of them, but they are useful to like keep track of notes inside your thing that won't break your computer. You don't have to follow Python syntax. You could just write in regular English. All right. So conditional control structure is generally it's in Python. We've seen the beginning of it is just an if statement. So what we're going to do is we're going to define a function where we could show this control structure. And I'm just going to use something fairly simple, compare two numbers together. So I'm going to do another function by using def for short for defining, or define. And I'm going to say, man, what's with my spelling today? So compare numbers. I'm going to use numbers for short for numbers. And then the opening parentheses. And this I'm unlike our hello function, I'm going to pass it some what we call arguments. So these are things that can be passed to it when we start. So we're going to want to give it two numbers because we're comparing two numbers. So we'll give it a number A and B. These could be anything. These are variable type names. So we could put num1, num2. We could put XY. It doesn't really matter at this point. We're just letting this interpreter know that when it reads through here to expect there to be two inputs to this function. There's going to be there's going to be two inputs every time. All right, and then we do colon to show that that's the end of our definition, and now expect a code block for the actual function itself and what's going to go inside of it. And what we're going to do here is we're going to use our if statement again, and we're going to check a condition. So we're going to say whatever logical condition we like, and this time we're doing comparing numbers. So we're going to want to say something like, if A is larger than B, do a thing. So similarly to this if statement down here, we end with another colon. And then when we hit enter, it's going to bring us down to yet another indented block. So there are 8 spaces of indentation here. And we're writing our code within this if statement inside of the function, right? So now we're comparing A and B. So when the computer reads this along, it's going to say, all right, cool, there's a function here. And it's going to check to see if this is true. And if it is, it'll enter this code block. And what we want it to do is just return something to us. And we'll just do a string. It says A is larger. So that's somewhat like what we did down here, where we had an if statement and then we return something. But that's not quite good enough for this scenario because what if B is larger? So we want to put in another condition. And there are a couple ways to do that, but the one where we are expecting there to be yet another condition, if we follow this all the way to the end, the last conditions could be is they could be equal, right? So there's 3 conditions that we're looking at here. We don't want to just have a catch-all for the next one. We want to do another comparison, and then we're going to have that final catch-all of these 2 numbers are the same number as the last one. So the way we do our second of many conditions to look is combining the words else and if into one word called elif, E-L-I-F, no spaces. And it needs to be followed again by another conditional statement of some sort, some sort of logical condition. So we're going to say if B is larger than A. Whoops, nope, not smaller than. That would give us the same thing as the first one. Or we could say A is smaller than B, whatever you like. This isn't a logic class. This is just to demonstrate the syntax of Python. So we're going to return that B is larger in this case. close our string. All right, now the last case that we need to cover here to make this comparing two numbers complete, still inside of our definition of this function, we're going to put our final case, which is just called else, and then colon. So there is no condition that goes with else, because this is the catch-all. This is like, if no other conditions have been met up to this point, this is what I want you to do. So we're going to put in return A and B are equal. Cool. So this is just showing us that we have our first condition is going to check to see if this is met. If not, it'll keep reading and it won't even enter this code block at all. It'll just keep going. It'll check to see if this condition is met. If it is, it'll return this. If not, it keeps going. And this is the else condition. So if neither of these conditions are met up here, it will go into this code block and run this code block. So to do that, just like we did with this pattern, we're going to give it some information to begin with, and then print out our results. So inside of this print statement, since we didn't put our print statements up here, we want to get in the habit of returning something from our functions. And we'll print our outputs using the print down here. So we'll do a couple examples, do compare nums, and then we'll do some numbers where we test each of these conditions. So first we want the first one that we put in to be larger. So let's put 8 and 3. Make sure we have a close for our print statement. And then I'm just going to enter a couple other ones in here and copy this so that we have a few test cases all together to test, our full number of possibilities that we have. All right, so now we expect to get the 3 different results that we have. So we expect the A to be larger in the first case, B to be larger in the second case, and for them to be equal in the third case. And so we run this when we save it, first of all. So we got to save up here at the top, click save, or you can hit Control S like you do on a Word document. Okay, so we can run this here in the console if we wanted to. We could just hit run right here and run it below and see that. But we could also call it from this top one. So I renamed this to remind everybody up here, main.py. So if you're following along with me and you renamed it into hello like we did before, call it whatever you've named it. We're going to keep it a main, just as our convention. And when we do this, we should see the 3 outputs that we expect. So we got A is larger, B is larger, and then A and B are equal, which is what we expected from this. So that is an example of the conditional control structures using if logic. So you if, check a condition, elif for a second condition, and then else is for your final catch-all condition. Any questions about that?
You can have more than one elif, right?
Yes, good question.
You can have
do
3,
this
4, 5.
Yeah, you could do this kind of endlessly on as much as you like, as much as you need. Maybe not as much as you like. I don't know how much you like it, but it's as much as the problem requires you to do it. You can keep adding elifs in there. Any other questions?
How many else if?
So can we run this now, or do we have to save it first?
You always save it before you run it. Yep, always get in that habit. Just do save then run. It's like a pattern that you got to follow every single time.
Okay.
Cody, you got a question?
Yeah, how many LF is too many when scale becomes a problem?
Great question. So we will talk more about scale on Thursday when we talk about how to pick any algorithm or write algorithms for efficiency. Honestly, I think it would be pretty hard to write enough elif statements to make it become a computing concern.
Okay.
Like it physically take you a long time to write that many statements. I can't imagine a scenario we'd run into that many possible logical, choices. It doesn't usually get that long. And if you are doing it that long, you might want to rethink why you're writing that many elif statements and see if there's some other way to do what you're trying to do. And
your
construct
algorithm may have a flaw.
Yeah, it might be a bad algorithm. Which, so we talked about like when we go back to the example when we made the sandwich, and everybody noticed. It was funny. So there's a couple of things I noticed from that. First of all, everyone starts with peanut butter, which that may be the linguistic influence of we say peanut butter and jelly, and that's why everyone starts with peanut butter. But also, that's the second time that nobody cleaned off the knife between the peanut butter and jelly. when we do the code review, quote unquote, and we say, okay, who else would have done something different? Everyone says, oh, you had that paper towel or that rag you didn't use. But in reality, no one uses, like, who uses a rag when they're making a PB&J? You use the bread that you didn't use yet and wipe the knife off on that. The point being, though, that there's several techniques to get to the same thing, right? So keep that in mind with these two. If you find yourself writing a whole bunch of code, and especially if you're doing something repeating yourself, there's a general concept called do not repeat yourself, DRY or dry, in designing software and code, that if you find yourself doing a whole bunch of the same thing over and over again and pasting and copying and stuff, you might be doing something you want to rethink. So does that kind of answer your question?
Yes, it does. Thank you.
Excellent.
You
Sure.
want to hear a scientific explanation of why you start with the peanut butter first?
Sure.
Okay, the peanut butter is more viscous, right?
Okay.
So it's more stickier,
All right.
and the jelly is more watery. So it's easier to spread a less viscous substance on a viscous substance than it is to do it the opposite way.
Man, now you're talking about spreading it on the jelly. We're gonna get a whole like philosophical debate about peanut butter and jelly. I didn't mean to get that deep with it, but that's a fair argument. That's a fair argument. It could be a physical property, not the linguistic influence. And I, as typical categorical people, see everything as linguistics because I'm a linguist. So, you know, you could be right. But cool. Any other questions about conditional control structures? The if, elif, else statements before we move on to our next control structure.
Okay. I'm gonna run this and see what
Is
happens.
there
Let's do it.
sugar and garlic?
All right, cool.
butter?
Let's do our next one, our next control structures. There's two sort of types or two different kinds within this general type that are called iterative control structures, meaning that they could go through iterations and they go through several rounds of doing something. And they're very aptly called generally loops. So there are two kinds of loops that you're going to use a lot. The first one you're going to use all the time, and it's called a for loop. And keep this in mind. For loops are great. They're kind of slow, but they are a wonderful place to start. So a for loop conceptually is going to take any of those data types that we talked about on Thursday, the four data types that are collections of things. So we got the lists, the tuples, the sets, and the dictionaries. Those four data types are also what they call iterables, meaning they can be iterated through. I hated that word iterable when I see it in documentation because they're like, oh, you can do this with any iterable. And I didn't know what they were talking about. That's all they mean. They mean something that has a number of things, that generally has a number of things inside of it, and that you can go through each one and do something with it in a loop, right? So a loop is a way to tell a computer to take one of those things, a collection of things, and do something to each one of the things that's inside of it. Make sense conceptually? All right. So how we do that in Python is very simple. It's another set of reserved words, or just one reserved word, really. But we're going to put this in a function again to keep our habits clean. So we're going to find a new function, and let's just use this to show the items that are in a list. So I'm going to say show list items, and it's going to have take in as an input or as an argument a list. I'm just going to shorthand that with ls, because list itself is a reserved word, so I don't want to use that for something. But this could be anything. This could, I mean, you could put in kind of gibberish. It follows the same conventions as any other variable in Python. All right, so inside of this function of showing list items, what we're going to do conceptually is loop through a list that we have passed it. So this list is going to come in, and we want to loop through it and just print each thing that's inside of it. So it's going to be very straightforward. This one, I'm actually going to put the print statement in here so that it doesn't, just to make sure it doesn't break. So for, we're going to say item. Now this part right here is, again, a variable name. This isn't something you could call this anything. This could be X. This could be, a lot of times people just do I because it's the thing that is being iterated through. Sometimes like being explicit to say the item in, so that's the second reserved word, as you can see is in blue. Say for space, variable name of your choice, in, and then the list that we're passing it. So in this case, it's this variable name. So what's going to happen when it gets to this block is it's going to start, the interpreter is going to read this and say, okay, cool. So I have a list. I have a for loop, first of all. I have a list. So I'm going to look at this thing, and I'm going to take the first thing out of it, and I'm going to assign it to a variable called item. And then I'm going to do whatever is in this code block to that item as like the first thing that's in there. And so all we're going to do is we're just going to print that item from this command. right? So that each time it goes through, it's going to print the item. I know we're kind of breaking from, I said, get in the habits of put and return. It's okay. We're gonna skip this. We're gonna do a little bit different this time, and we'll all live. So we do have to call it the same way like we did before. So we have to first of all have a list of things. So I'm going to make, a list down here and put some stuff inside of it. So we can put anything in there, but let's just put some numbers. 3. You can see I don't have to really be that careful with my spacing between the items in here. Python doesn't care. Close out my list. And then we'll call our function. So we'll say show list items. And we'll pass it my list. Let me space down a couple of spaces so we can see it. All right, so now when I save this, and we can, again, you could just click this run button up here if you really wanted to. It's going to open another console if you have space for it. You could do that, and it'll run in the console down here. But I'm going to run it back in the bash console the way we have been. So I'm going to run it the same convention to show that it works every time, no matter what else we change in that code. And so as you can see, it printed out all the numbers from our list on our own line. So it just went through on each round. So the first iteration, it came through and it pulled this one, assigned it to a thing called item, and then it printed that thing. And then it did that for 2, 3, and then all the way up to the end of the list. And that is a for loop. Very simple, very slow. So when we get to algorithmic choices and efficiency, this is the kind of thing that's very good to know. It's unavoidable. You got to use them to a certain extent when you get going, especially when you're first starting out, especially in some cases, you're not going to be able to get away from them, but there are more efficient ways to do things than for loops once you get a little bit more complex ways of doing it. So don't rack your brain with that. Just learn these well first and don't be afraid to use them, but it becomes an issue of scale we could talk about on Thursday. So any general questions about for loops?
Okay, the placement of when you're placing different calculations within the program, right?
Mhm.
I mean, you start with A and B are equal, right?
Sure. Yep, this right here.
This is basically in the same, this is in the same code, right?
Oh, yeah. So this Python understands these things as being different just through the indentation. So all of this stuff is, we're just writing it straight. As you can see, all the definitions are they're right up against the edge.
Yeah.
And then once we enter a code block with a colon, we're always indenting, and it expects an indented block, right? So if we didn't have that for some reason, and I save this, first of all, the thing should yell at me and give us little errors as syntax error.
Yeah.
And it'll highlight us to say that's not right. But yes, this is how Python understands that, like, this definition of a function is different from that definition of a function, because there is indentation here, and then there's a return statement, and then there's no indentation here. And this is a new definition. So these things are breaking it up for it, and you don't have to explicitly tell it where the ends of things are like you do in some other languages where you have to close everything with some kind of bracket or something. Python just uses the spacing, what they call indented code blocks.
If you're just giving an input like a list here, right? Then it'll just know to kind of step over the ones where you're comparing B and A.
Oh, you mean if I defined like my list up here, you mean?
Well, I guess what I'm curious about, because when we started out below below the if statement, right?
Mhm. Yeah.
Okay, we started out with a list of compare numbers, right?
Oh yeah, when we had compare number before, yeah, sure.
So if you have this other code up here somewhere, which is just sitting there waiting to compare numbers, and you don't pass it anything, then it just doesn't do anything, right?
Nope, it does nothing. So if you don't call it down here, it does nothing. So these two right now, I could just erase them or comment them out, and I'll do that now. So I'll highlight all of these. There's another kind of shortcut, and you hold down Control and hit slash, and it'll just comment like entire blocks of code. And that way the interpreter won't run or even read any of this at all. So if I save this, since I don't call any of those things anywhere, I just call the show list items. This should work exactly the same way. There should be no change in how it works. So if I go back here and run it again, as you can see, it does exactly the same thing because it made no change. But if I try to call one of those things that's commented out, like this compare nums, if I try calling that again, let's see what happens. I'll give it two numbers, just, 5 and 6. I'm gonna save that. So there's, give me a little warning. So this says undefined name, compare nums. So that means that the interpreter, when it read, so what it's doing every time we save it, and when we go to run it, what it's going to do, what the interpreter does ahead of time is it kind of reads the file. But when we run it, the Python interpreter reads this top to bottom, and it just checks all the definitions that exist. And then if you call something that doesn't exist, it's going to say, no, that doesn't work. And it'll give you this name error right here. It says is not defined. And that means that you just didn't have it.
Yeah, it's looking for an input it's not getting, right?
Right. It's looking for something that doesn't exist. So then I want to save that and get rid of that error over here and go back here and run it again. Now it should work just fine, except I didn't print this statement. I just did compare. So I'd have to put this in print to make something actually come out to the console. But it didn't break. It didn't give us an error. So hold on. Now this is getting nasty. Let me clean this up a little bit. And we'll run it again. So Python main. And now you can see that I got the compare function is in there now as well.
Okay, yeah, all right.
So it's again, anything that's in the block of code. So after this colon and inside the indentation, after our entry point, our app entry point, all these things that are in here, this is what's going to be run when you actually run the code. And so that's why I write these things down here to remind us of that you can define all kinds of, you can write, pages and pages and pages of code up here. But if you only call these two functions, those are the only two functions that are going to run.
Okay.
That makes sense?
Yes. Perfect sense.
Right. Cool. Any other questions? These are good questions. Any other questions about anything up to here? The conditional statements, why we're writing them kind of the way we are, the for loops.
So basically that's just a working storage area, right?
Kind of, not really. I don't want you to think of it that way, because then you're going to start tripping yourself up later when we have, memory as a storage area and storage as a storage area. This is the code. This is actually, so think of this as when we were making the PB&J. This is the steps to make a peanut butter and jelly sandwich. This is the SOP. This is the pass down log for the guard duty that you give to somebody and say, this is how you stand guard. This is exactly the directions every single time. The computer will follow it exactly the same way. So this is writing down the algorithms. These are algorithms. This is an algorithm to compare two numbers and see their relationship. This is an algorithm to see everything that's inside of a list. And you're just writing down these directions, these algorithms, and they're here. So yes, in a sense, they're saved. But again, I don't want you to think of the concept of storage in this. Well, this is the file, a file in a directory. That's the concept I want you to remember. Okay. Is that it's a file just like you write down a text file. This is text in a file. It's just we're telling it that it's written in Python instead of English or something else. And so the interpreter should read these, these spaces are relevant. And when it reads through these things, that is some compute power. Like there is some power being taken on each line of this to do this. So it's, if you're not using the code, you should throw it out. But, and there's some memory being used in the sense of, like you store the file. So if the file is really big, it's going to take up some more memory and some storage space doing that. But yeah, this is the file that your application is. Like the application is this. There's no difference between this. And it's like, again, Google in all its glory and all its stuff is somewhere is a bunch of files like this that has all the definitions of everything that it does, its search algorithms and all that kind of cool stuff. It's written in, other languages, but it's written a lot like this in files, exactly like this.
Okay. So this is basically where we define things that we want to call.
Yep. Yep. And we're going to use them. And then I'm going to show you again how to do a little more of this where these things, why we're doing it from other places, kind of makes a little bit more sense too. But does that make sense? What we're writing up here is our set of directions that every time we tell the computer to run, it's going to follow those directions every single time.
Correct. Okay.
Cool. All right. Nice. All right. So let's go through our next type of loop. It's our last control structure before we dive back into arguably the coolest part about Python and I really want to get to, but this is also pretty cool. So these are called while loops. And I'm just going to write that down here. While loops. Now, while loops are a lot of fun, but they're dangerous. They can go endlessly. So similar to a for loop, they check to see if a condition is that. Well, actually, I'm sorry. Similar to an if control structure, they check to see if a condition is true. And while that condition is true, it will execute the block of code that you give it. So if you never change that condition, it'll just keep running the block over and over and over until your computer dies. So Python Anywhere has some fail safes in here that'll show you that it'll stop and it won't break anything. And that's another reason why we do it in here, because you're not going to do any damage. But if you do get caught in an endless loop, you know, you close things out and stop your browser. That's why doing a browser is safer. If you're doing this on your own computer, you might crash your computer with one of these if you're not careful. So it's not, not the end of the world, but it is somewhat dangerous. So we're going to do the same thing we did before. We're going to wrap this into a function that we can call, and we'll do that convention again. Except this time we're going to do something that all right, so we're going to come up with a scenario in which we would want a while loop, like something that the condition is going to change, and we're going to check that condition over and over again, and we want it to stop after a certain number of times that it's gone through, right? So what we're going to do is make a function that's going to fill up an imaginary container. So imagine we have a box, and we're putting stuff in that box, and we don't want to overfill the box. We want to stop putting things in as soon as the box is full. So that's the function that we're going to make, right? So we're just going to call it container filler because that's what it does. And it's going to take a maximum amount of things that can go inside of that container. So we're going to pass it some integer. We expect that to be an integer. There are, Python ways of writing what we expect it to be. We'll leave that out. There's style things in there. We know that this is going to be an integer. Let's leave it at that. And we're going to enter a code block here in our definition like we have several times. So now we're in an indented block. We're over 4 spaces. And we're going to define what this function is going to do. So the first thing that we want to do, since we know we're going to be using a while loop to do this, what is very often done is we'll set a variable that is going to be a thing that is going to change, that will allow us to compare to this maximum size, right? So we're just going to give it a number, and that number is going to go up each time that we go through our loop, each time we use our while loop, and we're going to compare to see if it's the same as the maximum. And as soon as it is the same as the maximum, we want our loop to stop. So that's the concept of what this thing is going to do. So the first thing we have to do is define our variable. I just call it count and set it to 0. So this is just holding a spot saying that our count starts off at nothing. It's again, assume that you have an empty box. It's like counting the things in the box. There's 0 things in the box, right? So here we go. So we know our count is 0 when we start. And then we do our while loop. And it's another reserved word, just the word while, W-H-I-L-E, space, lowercase. And we're going to take our count. So now we're doing a conditional phrase. So this is some sort of logical phrase that we need to put in here where we can check to see if something is true or false, or if it is or is not that thing. So we're going to see if the count is less than the maximum that we put up here in the top, right? That we initialize. And it's going to say that the size of our box, or the capacity of the box, is the maximum. So as long as the count is smaller, while, so if we just read this almost in natural English, while count is less than maximum, do this code block. So we're going to yet another indented code block. So we should be 8 spaces over. And we're going to do a couple of things. Now, best practice here, and this thing I just really advise you to do, is if you're doing a while loop, put in the changing condition first, so you do not forget and get yourself in the endless loop. So since we're checking to see that the count is the same or is less than the maximum, we're going to increase our count as the very first step inside this while loop. So to increase something, to increment something up in Python, we do plus and then we set it. So we do plus and then the setting assignment, and we just say 1. So increment by 1. So we're just going to go up by 1 each time this runs through. So we do that again. So we say count, increment up by 1. And just if you're curious, you could put this in as a minus sign to decrement and go backwards and go down if you wanted to say like count is 100 and we had a minimum or something like that. But since we're going up from 0 with a maximum, we're going to do plus and increment up by 1. And then we're going to do something with this. So the count's going to go up, and then we're going to just print as an output each time what the count of our box is, or our container, what that is. I'm going to show you another kind of cool trick that we're going to use a few times moving forward in Python. And this is a way you could format strings. So just the letter F, lowercase, and then we're going to open our string. So no spaces, just F, the open quotation mark to put in a string. And then we put in our string. So we'll say the container has, and now if we do curly brackets, curly braces, opening curly braces, we can enter in any of the variables that we're using in this function. So I'm going to put in my count variable, close off curly brackets. So what it's going to do is it's going to take that count each time it runs through. It's going to put it into this string. and print it out. So the first time it runs through, it should say that we have one thing in there, then two things, and then all the way up to the maximum number is what we expect this to say. And then we'll just finish off the statement to say how many items it has. And that's what's going to happen when we run our container filler function. So it's going to return each time it runs through, it's going to print out and tell us how many items are in there and what our count is. And that's going to be, representing the number of items inside of our thing. So I'm going to remove this stuff that we had down here, and I'm going to try this container filler function to see how it goes. So because we have a print statement here, we don't have to print out anything else. We're not doing returns, we're just doing prints. So I'm just going to call this a container filler. And then I don't want this to be huge, so I'll just say 5 as our maximum. Again, we expect it to be an integer. So I'm going to save this. And when I go back to our console over here, clear this up. Yeah, clear. All right, now I'm going to run our main Python file again. Cool. And as you can see, our maximum was 5. And each time it ran through and it gave us our full string that says our container has 1 in there, 2, 3, 4, 5. So each time it looped through. And while this was true, it printed all that stuff. And then as soon as it was not true, it stopped and it broke and it finished, and it didn't break our computer. So that is a while loop. Any questions about that? Chris, if you're asking a question, you're on mute. I can see you talking.
No, I was just going to say I burned myself on that too. Where you place count plus equals 1 can matter. It can be after the statement if you need it to add after it's done its action.
That is a great call. So sometimes, and the placement of that. So I say
and
that
then
is
you got to
important.
count equals 1 is where you start, and then you're adding 1 later. So yeah, I mean, it has effects. So how you
awesome.
choose your algorithm can burn you.
And here's, I'm going to show you that. So I just moved it to after the print statement. I'm going to run it again. And so we expected, like you said, now it's 1, now it's off by 1. That's off by 1 error. So it says the first time there's 0 items in there, but really the first time there's 8. So if we did some kind of other calculations in here that we're expecting this value that we see here to match up with something, this would be off. This would be giving us bad information.
But if you're using that to iterate through an array, you want to start with 0.
Exactly.
So you want the 7th thing in an array, you need that to be at a certain counter and find that thing.
So the key takeaway here is it does exactly, to your point, matter where in your algorithm, at which step you do this increment. And it's going to affect, again, it's to what the purpose of your algorithm is going to dictate where you put that. I said to put it in first, just so you don't forget, but that's a great call that it doesn't have to come first for this to work. It's just, if you don't put it in there, you might forget, and there's going to be an endless loop and it'll just die. So actually, let's see what happens if we don't put this in here. So it didn't, I'm just taking out the increment step entirely. I'm going to save it. I'm going to run it. I'm expecting this to crash. That's what I expect this to do, but let's see what happens. Oh, see, so Python anywhere. Hopefully I didn't use all my compute power doing that example. And hopefully we can still do the rest of this. Because if I ran on all compute power, then I got nothing. But apparently I'm obnoxious for every other user. And it's only I'm interfering with everybody else by doing that. So this is sort of an example of why you don't want to just let your while loops just go, because it's going to run. I mean, look at this, how many, I'm scrolling up still, and it's got 0 items in there each time, and that's printing out a ton. So actually, now I'm kind of curious to see if I use all my compute power. Oh, no, I didn't. Okay, cool. I'm looking at this number right here, the CPU usage. I've only used 4%. And you have a limited amount, right? So every 8 hours or something like that, it'll kill us. Oh, it killed my console though. See, look, I have no more consoles. So it's a new bash console. But yeah, so that's the example of why you don't want to forget to change your count and iterate up or increment up in some way, or else you're gonna break your entire system and nothing will work the way you want it to. So good call on that though. Yeah, where you place this is dependent on what you want this algorithm to do and when you want the thing to increment. So yeah, excellent point. Any other questions or comments or things that you noticed?
So in this particular configuration you have right now, with line 23 count, it would never print 0, right?
No, it would not. It's a good question, because this is starting at 0. To get it to print 0, I have to start at -1, which I could do, but there's no reason for it to start 0 because, again, we're thinking about this algorithm in the context of the problem we're solving. The problem we're solving is filling a box. You're not going to have negative items in a box,
Yeah,
right?
okay.
So, and it would be irrelevant to say 0 because we started out as with an empty box. We know it's 0. So,
So this routine, we could save someplace else, copy it and save it. And whenever we ran into a situation where we needed to have a counter, then we just go copy it and paste it into the program and run it.
yeah. Or you could just, and that's the other thing, you just reference it from wherever, right? So even if we're in a different file, we can run this Python program and it'll run just the same.
Oh, okay.
So even if I'm down in like my root folder way out of where I was before, I could do the same thing. If I can remember where this is, it's like in /home, and then Zoom stuff's in my way. All right, so this is the full path from where I am to that file, and it should run exactly the same way because you could call these things from anywhere. And that's, again, the whole point of that entry point that we set up is so that this could be called from all over the place. I don't have to be in the same directory as my working directory. I am now, but I wasn't when I just called it originally. So when I call it with this full path, the same sort of thing, you call this from anywhere. So once you write this down and save this as an application, it could be called from wherever you need to. And that's sort of like the broader thing of plugging into some sort of framework outside of this, right? This is the application here. It's accessible because of this entry point from outside, from other places.
Okay, so you did the CD to change directories, huh?
Yeah. Sorry, that was another quick Linux thing. That's changing directory stuff. Definitely worth knowing. Cool. Anything else? I want to jump into the last, and it's seriously one of my favorite parts of Python. But I want to make sure everybody gets this conceptually that we're pretty solid with this. I know it's obviously not going to be 100% solid. Definitely go through those Pythons for everybody lessons from Free Code Camp and the other Python things that get more hands-on with this. And the algorithmic practice that I send out at the end of today will give you plenty of opportunities to use these constructions over and over again and practice them. So that's huge. And we'll get to that after I talk about this next thing. The last thing we talk about are the algorithmic practices, and I'll send out that data, the problem set for everybody to mess around with. But these are the pieces that you're really going to need for that. So make sure we're at least conceptually clear up to now. All right, cool. So the next thing we're going to talk about is a data type, right? So we did our control structures, we did our sequential control structures, how Python reads things top to bottom, left to right. Normally, we did our conditional if statements for control structures, and then we did our loops, so the iterative control structures, the while and for loops. Now we're talking about the last data type in Python called classes. Now I saved this to talk about because it is most complex, but it's also like the fundamental thing about Python. Is the coolest part of Python. Python is what's called an object-oriented language. I didn't lead with that when we started talking about Python because I don't want you to get really wrapped up. Sometimes that can get super computer sciencey on what that means. But classes are really the thing that make that possible, right? So the way Python treats pretty much everything is it treats it as this object in its world, and objects all have some sort of attributes and they can do things, right? So classes are ways of defining these objects in your world and then doing things with them. So I'm going to show some examples of classes, but I want to kind of try to explain it conceptually first. So the example we're going to use is cars, right? So a car class in Python, if you think about a car, right? And when I said car right now, I guarantee you're all thinking about something. It's probably like a sedan looking thing. It's got probably 4 doors and 4 wheels. But we know that there are certain attributes that define a car, right? It's got a hood, it's got tires, it's, you could drive it. It does things, there's things that it can do, some methods that it can follow, like it can drive, it can, it can be cleaned. But you also know that that's part of a larger group of things. It could be transportation that can include planes and stuff like that. But planes aren't cars, they're different. They have different attributes. They have different things that could do. They could fly, not drive. And you also know that they're individual cars. Like you have a car, maybe you've ridden in a specific car, not like a general car, but like a specific car, a Honda or a Toyota or something like that, a specific type of car. So classes in Python are ways of defining those broad groups, say car, and say all cars have a year, a make, a model, they have tires, they can drive, and it's writing that down and saving it. So then when you make a program and when a program runs, you can make an individual car, an instance of that class of a car, and do something with it within your program. So I'm going to show you how to do that. That's just kind of generally the concept. And this is something that, again, I want to make sure everyone understands. Classes are great, but if you don't fully get it today or right away, don't worry about it. This is exposing you to the idea, showing you the structure of them. We're going to use them a lot. But they are a little bit slippery. They're a little bit tricky. So don't freak out if you're like feeling a little lost at the end of this, and ask questions along the way, because this is good stuff. All right. So to demonstrate this, what we're going to do is we're going to demonstrate again a couple other things, a couple other concepts along the way of this modularity and going through this if statement. But to show classes, we're going to open up a new file and we're going to move to something different, and then we're going to pipe these things together so that we can run them. But quick note, if you do have in your dashboard, if you've got more than one console, I guess here you should go to consoles. And if you have more than one console, we're going to need two, or we're going to need another one. So close out your second one and make sure you have one available for this next part if you're following along. And then we're going to go over to files, and we're going to make ourselves a new file. So go to files. So you could do this in the command line if you want to practice you're making files. You could do it here if you like. I'm going to show here again. So we're just going to do classes.py. We're going to make a file called classes.py. So I'm in files in Python anywhere. I'm going to hit this new file button. And what I do is going to take me directly into the text editor. So now we're in here. All right. Now we're in another file. Should look familiar from our main.py, but we're in classes.py. Nothing in here. All right. First thing I'm going to do is I'm going to do that same conditional thing that we talked about, because it's such convention. The if underscore name is equal to the string main with 2 underscores. Do something. Now we just got this ready to go. So we can run this classes.py file in the way that we have. And then I'm going to start defining some classes, and we'll start doing some things similar to what we did with defining the functions, except there's going to be classes. All right. So, excuse me. The way we define a class, very straightforward. Similar to the other things we've done in Python, there's a reserved word involved, and it's just the word class. So class, lowercase, CLASS, and then space. And then when we name a class, we're going to do uppercase. We capitalize the names of classes. This is a naming convention, unlike the things that we've seen up to now that have been lowercase. We capitalize the names of classes. And then we're going to do this again in very, very basic ways. So we're not going to have any parentheses. There's nothing that we're going to pass to this directly. It's just going to be the word car capitalized and then colon. This is how we define our class. So now it goes into a new code block, and we're going to start giving it what's called attributes. Now, attributes look exactly the same as variables. They're defined the same way. You make them the same way. They're just part of a class, right? So let's give this thing just some example ones. We'll give it a make, and we'll say that we expect that to be a string. We'll give it a model. We expect that to also be a string. And then we'll give it a year. And we can also say that's a string. We can say this is an integer. Doesn't really matter. It's a placeholder at this point. And we can set it to something else later. But, for now, makes no difference. All right. So this right here is a very basically defined Python class. So what we've done is we've said, okay, there is a thing that exists in our world called a car. This thing has a make, it has a model, and it has a year. We expect the make to be a string, the model to be a string, the year to be a number. That's all this is saying. We don't have a car yet, though. There is no car. This is just the idea of a car. So that's what I want you to kind of get this concept, is that this is just the idea. It's like you're telling the computer, I got this idea for a car. It's a thing. It's got make, model, year. That's what it has. And now in our entry point in our app, we have to use Python to what's called instantiate this class and make one of those cars. The way we do that is we're going to save it into a variable. I'm going to say my car is, and then we're just going to call that class that we defined, the capital CAR, and then we're going to do it the same way we did functions. So this is called instantiation. You're making an instance of this car class when you put your open and closed parentheses in here. So now that we've done that on line 8, we can do some things with it. So it's just going to have empty strings as our make, model, and year. So we can set those things now that we have our class instantiated. So on line 9, I'm going to set what we want this to be. And the way you do that is you say my car, so the name of your variable. So it's the instance of this car thing. And then you say dot, and that's how you access any of the attributes. That's how you access any of the, what we'll talk about next, called methods, which are the functions associated with the class, is through this dot notation. So you do dot, and then you say make, and then you just set it the way you set a variable. So is, and then we'll do doesn't matter. Why can I not spell the most simple words? Okay. And then we do that with the other ones. So we say my car dot model, and then it says Camry. And then we'll just give this a year. It makes no difference. Oh, don't want to do that. Year equals, and this is expecting an integer, but we could put a string in here. Again, it's not going to break anything. It's just going to, these are just placeholders up here, but we can give it an integer and it'll work just fine. So let's say, you know, it's a, I don't know, 2020 Toyota Camry. So there we go. So now we have these things. What do we do with that? So let's make sure that we have it by printing something out, and we'll use our formatted string again, and we'll just say IMA, and we'll use our variables. So to reference those things, we'll say my car dot year, because this is kind of the standard of, like, if we say what kind of car we have, we say year, make, model, you know, like 2020 or 2020 Toyota Camry. So we'll say my car dot make inside curly brackets and a space. Again, we're doing this inside a formatted string so that it will give us the variables in there. And let's close this off, close our print statement. Cool. Now we save this. All right. So now we know from before that if I go back to our console, we could run it directly from the console now that we've saved it. But we could also just run it here. I mentioned this before. You could do that from here and run it. And I'm going to do that. It's going to open a second console right here. It's just going to do a bash console and then run it similarly within the Python shell. As you'll see, it's going to open up those little things. And there we go. So here's our output. So it says I am a 2020 Toyota Camry. So it did give us the formatted string that we expected. So we go through that line by line. On line 8, we initialize our car instance. Then we set the attributes in the subsequent lines. And then we print out all of those things that we just set. So this is, in essence, what classes are in Python. And the reason it's so important is that literally everything in Python pretty much is a class. So every time you make a string, so I'm going to do this just down in here as a quick, because it's just a Python interpreter again. So let's do just my string equals, you know, this string. This is technically a string class, and each string class can do something. This is an instance of a string class. And so if you look up in Python's documentation, the string class, it'll give you a list of all the things that it has that are attributes and methods, which are what we're going to talk about next, the functions that are built into it. So it's really important to understand that, like, this is what Python's kind of doing all the time, is it has some sort of representation of a thing. It's called the parent class. And then every child, every instance of that class inherits all that basic stuff from that definition that's written down someplace in a file somewhere, in a file that you're referencing every time you make a string or make a whatever you're making. So this is a way that we can make our own classes. And these are attributes of those classes. The other important part before we take not break, but, like, you know, break for questions and see if anybody's totally lost, is something I mentioned a couple of times already. It's called methods. So one of the beauties of this is that we've written this sort of template up here for a car class and say, okay, cool, a car's got these things. And then when we make one, we can set all this stuff. Let's say I wanted to make 2 or 3 cars. Let's say I wanted everybody in this class to have a car. And I could do that, and that would be great. But then I don't want to have to print out each single time, like each individual time, like write this statement each time in its entirety. So what we're going to do is we're going to make this a method of this car class and say the car could just tell you, you know, like a label on the car where you walk up, you can see it. You can see what the car's year, make, and model is. You know, maybe it's written on there what year it is. Maybe it's that good. You know what years are. But we're going to make this a method of this class. So it's the same way we've been defining functions up to now. It's just going to be inside of this class. So when I say inside, is indented 4 spaces inside of this code block right here. We're going to write def, just like we have been writing any function up to now. It's just this inside of a class, so it's called a method. Slight difference, and I'll show you that just in a second. So let's call this method something. What do we call it? Let's call it display details, because that's, again, the sort of example that I gave. was display underscore. So I got zoom stuff in my way again. So details. And in a method, unlike a function that was outside of a class, methods always take self as an argument. If you don't put anything else in here, it doesn't matter, but you got to put self in there because it's referring to the instance. So it's saying it takes itself as an argument, like it takes its own information. And then you can access these things about it. You can access the attributes of self. So what we're going to do here is rewrite this code. And this is an example of what we call refactoring. So I'm going to take this information, I'm going to move it around. The function isn't going to change, but the code's going to be written differently. So we're going to refactor stuff a lot. So the course is going to be one of the examples of it. So what I'm going to do is I'm going to take this piece that I don't want to be repeating over and over again, and I'm going to put it just up in here in this definition. So I'm going to take this whole print statement. I'm just going to cut it right out of here. And then I'm going to paste it inside this indented block. And again, we're inside the car class, and we're inside the method definition. So we're 2 indentations over. So that's 8 spaces. And now instead of my car.year and my car.make and model, we have to change these all to self because that's what we're referring this to now. Self. It's the self. This becomes very philosophical very quickly. We refer to ourself and talk about what things are. All right. Now we have defined this method, but just like the functions that we were doing over here in our main file, we have to call this function, or this method rather. We have to call the method. So down here where we instantiate our class and we make ourselves a car, a particular car, just like we did to set our, let's get some more space here, to set our attributes and to do reference to them and things like that, we're going to use this dot notation, just like we did before, except because it's a method. We're going to call the name of the method, so display details. And then we have to do the opening and closing brackets because it, just like a function, has to be called, invoked, right? So that's what these opening and closing brackets do. And there are no inputs. The self is implied by this dot. So the self is implied because this is a class, and all classes refer to themselves with their methods. So you don't have to write anything in here at all. No inputs. So when we save this, after making this separate function that we were just doing print all by itself, making it a method, this should operate the same way. When I run it just like I did, it should just print out again that my Toyota Camry. Hold on, that wasn't it. That was copying and pasting. All right, so let's click up here on run and see what happens. And there we go. It still says the same thing. It says I'm a Toyota Camry. And this will work just like it did before from our other bash console. I'm gonna clear this up. And we can see that we have our classes.py file here. So we can reference it just like we have with Python 3 classes.py. And it should run from here exactly like it did. Right? So that is our, our class. Let's go back to that file so we're looking at it. All right, so that is a basic rundown of what a class is. Classes have attributes, which are variables, and they're just the things about that class. And then it's got methods, which are some sort of function, some sort of action that it can take and do. Any questions about that? Any questions about how we use it and what's going on down here in our application entry point?
I got a question here.
Yeah.
Okay. Is the print statement and in the method and the print statement down below there, are those mutually exclusive?
No. So if you look down here in the bottom, it's really the same because there is no print statement down here in the bottom anymore. If you look, there's no print. I took it out entirely. So what I did was I moved it up to here into this definition of the method.
Okay.
So now it no longer exists down here. It's just called inside of this method when I make this method call right here.
Oh, okay.
How are you doing the copy and paste?
I see.
Oh, sorry.
See what you're doing here.
You see it? Okay. Yeah. What was that question, Scott?
How are you doing the copy and paste? I've been trying to do that a few times, and I missed the song.
Yeah. Sorry, man. Yeah. So I use hotkeys with just control. Copy was control C and control V to paste it. I'll do control X to cut it.
Gotcha. All right. Thank you.
Sure. All right, cool. So a couple other things I want to show about this while we got some time and sort of some other refactoring things that are very useful to know, and I want to expose you to them because they're useful tools, and I also don't want you to be confused when you see classes in other places, because these things that I'm going to go through now are so common. And when you're first starting out, you'll see a class written like this, and you'll think you kind of got an idea of what's going on, and then you go and look at somebody's code, and you're like, all right, I'm going to read and kind of study what's going on, and it looks completely different. You're like, what am I even looking at? So I'm going to go through a few more sort of standardized things. Again, don't feel, if this is feeling a little bit slippery, raise your hand and let me know, and we'll try to make sure that we're understanding. But all I'm going to do at this point is refactor this code a little bit and show different ways of doing this portion right here, where we set the values, so that we can break this down into one line and set our values when we instantiate the class. Because that's a really standard way of doing it. Instead of doing each individual thing with a dot call each time, we're just going to set it when we create it. So I'm going to show you how we could do that. All right, so the first thing we're going to do is we're underneath these attributes, we're going to define a new method. And this is going to be another one of the reserved methods. So it's going to start with double underscores. This is one that's by convention with 2 leading underscores, 2 following underscores, like we've seen before with a name, except we're going to put init, I-N-I-T, short for initialize. This is also something you'll see all over Python. It's used a lot. It's a real common thing to use. And this is just going to give us some information that's for initializing this class. So every time we instantiate a class, like we did down here on what's now line 14, this init function is going to run. And so this is a very standard thing to do with classes when they begin. So again, if we stopped here with a really basic version, and then you went to read somebody else's classes, they're going to have something like this a lot of the time. So I want to make sure you've seen these. Now, what we do with these, just like we did with the display details method, we have to put in self. So self is absolutely required. And we could just stop there and say, okay, cool, initialize self and then do that. But what I told you is we're going to try to make this a little more interesting and compile these 3 lines of code into one where we could pass arguments into this instantiation like we did with our functions. Remember, we passed this argument to do the container filler and stuff like that. So we're going to do something similar to pass in the information. Sorry, I saw somebody put something in the chat. I thought it might be a question. But yeah, those good. Like, yeah, no, that's good ones. Yeah, no, good one, man. That's fair. Okay. So, yeah, if you didn't see, it's just like some hotkeys to use in the chat there for copying and pasting and moving text around. Useful stuff. All right. So what we're going to do again is we're going to put these calls from these lines into this using this init functions. So the way we're going to do that, the first way we're going to do that is use a convention that's called arguments, right? So we're going to use asterisk, a single asterisk, and then ARGS stands for arguments. And what this is a built-in, that was a terrible phrase. This is a built-in list of arguments in Python. So this is expecting a list. So what do we know about lists? They are, who can answer this? Are they unordered or ordered?
They are ordered.
Ordered, exactly. So this is going to give us an ordered list of arguments. And what we could do with that is we can set our attributes to the values inside of that argument list. So what I'm going to do is I'm going to take these attributes, I'm going to just copy them and well, I'm going to cut them. So Control X, cut those out. And I'm going to move them inside of this init statement. So we're going to move them into this initialize method, make sure they're properly indented. So 2 indentations over because I'm inside of this function right here, this method call. And I'm going to change these placeholders to do the arguments that we want. So we know that make is going to be the first one. So we'll say when we're doing our ordered lists, it's going to be the 0 index. And we reference it the same way we referenced list items before. So we do the name of the list and then the index, and it's 0 indexed. So the first one is 0, second one is 1, the third one is 2. So we got make, model, year. That means what we could do down here is we could put our make, model, and year as arguments to the instantiation. So we can just take out our Toyota string and put it right in here. And then we put a comma, because our first argument is going to be separated by a comma, just like we did when we were defining this up here. Put a comma in between our arguments. So our second argument is model. So I'm going to take that out, put that in here. I'm just going to go ahead and delete lines 15 and 16 because we don't even need those anymore. And then I'm going to take the year, same thing, comma, move it up in here. So what I did is, again, refactoring, and move those 3 lines of code into this. This should, when I save it, should function exactly the same way. They should, if I did this properly, which I may not have. Oh, yes. What did I do wrong?
You need a colon?
Assigned but never used. No, I don't think so.
I don't think it likes the paste when you take like an indented line and you
It
paste
might.
the thing.
It might not. Let's see. Let's see if this kills it. I'm gonna try running it and see what happens. Maybe it really doesn't like it. Going all the way back to reload our. Oh, it has no attribute. Year. Okay. So, what am I doing wrong here? Can anybody tell? It's a bit of a trick question, but it's all in front of you. I didn't do this on purpose, by the way. I legitimately forgot something, but I just want to see if anyone here can catch what I forgot before
We didn't
before
have any variables for make, model, or year.
Okay. Yeah, you're on the right track, right? Because this is saying there's no attribute year. What does that mean? Attribute error. What's an attribute, first of all?
It's a characteristic of some individual.
Right. It's kind of what Cody said. It was a variable, but it's inside of a class, right? Now, how do we access our variables before? Like when we printed it down here, how do we access them?
You put
You didn't define the arguments.
yeah, you
Okay.
put the name of your class or of your instance,
Mhm.
dot year.
Okay. So then up here on line 4, what am I missing?
The instantiation, the dot notation.
Dot notation. Okay, that's right. But what should
Yeah.
go? Instantiation is down here. So we're not going to put it on an instance of it. We have to put it on what? You guys are so close.
The
Self.
It needs the at symbol. The at symbol.
Self. No, we need to put it on the self. So the self dot make is what we're setting here. So we have to put self dot make,
right.
self dot model, and self dot year. It's
Okay.
not the way that it was when we had make, model, and year out here just outside of this definition and not inside this indent. And we just assign them as attributes. So this has to say this self, its make is going to be the first thing in arguments. So when I save this, it should hopefully get rid of those warnings. And it does. And when I run it, hopefully, there we go. So that was an unsuccessful refactoring at first, and I broke it. But now that we've correctly assigned these things as attributes of that class by referring to itself, we've now successfully refactored this to where instead of having 3 lines down here, we just have 1 and we pass everything in directly. And that's using this args, which is built into Python, very standard to use, pretty easy to use. Generally makes sense?
Yeah.
Okay. Now, there's one shortcoming to this. Again, so this is a list, and lists are ordered. So if we entered this in a different order, like if I put, say, Camry here and Toyota there, we save it and we run it, it'll still run. The computer doesn't know. So it's going to say, it's going to say it wrong. It's going to say the make and the and model out of order of what we want it to be. So a way to get around this is we could use a data type that is not ordered.
Keyword argument.
Keyword arguments, exactly. So keyword arguments makes a dictionary instead of a list. And the way we access those is another built-in thing. We use 2 asterisks, and we put KW in front of args. So it's keyword arguments is what this stands for. And then the way that we grab these, since we can't, if you recall, we can't index, well, we can, if 0 is one of the indexes that we make in the keywords, that'll be fine. But it's not going to be. Our keywords are going to be make, model, and year for human readability. We're going to use those same conventions, and we know that. Like I know that we're going to make our keys those strings so that it lines up. So what I want to do is just enter those in here as strings. You remember that's how you reference the key inside of a key value pair. You reference the key and you'll get the value back. So by referencing each of these keys, let's turn this into keyword arguments. So we're not getting the list anymore. All right, and I'm going to save this. But first, we have to do one more change down here. So order doesn't matter. So these could be in any order they want, but we have to tell it which value it goes to, which key we're giving a value for. So, you know, Camry, that's our model, right? So we're going to say model equals Camry. Our make equals Toyota. And equals, this is, I'm setting these to those values. So I'm saying that the make is Camry, the make is Toyota, the model is Camry, the year is 2020. As you can see, it's in the same order that I gave it before as a list when I was using the arguments, and it came out wrong. So this time, since it's unordered, and we're assigning these as they are, and then this is ordered the way we want it to be, this should fix our ordering problem, and it doesn't matter what order we pass these into because they're keywords now. So let's find out if that's the case. I'm gonna save it. I'm going to run it here. And there we go. So now we have the proper order that we want, where it says, I am a 2020 Toyota Camry. It says year, make, and model the way that we say it conventionally. So that is an example of refactoring. This is where you're going to see this a lot in Python, where people have both of these just written into their stuff, and then they don't do anything with them because you can have 0 or more arguments or keyword arguments. So they'll just start with this as a full on, this is like the standard thing that they have in there. And then they start setting their attributes and doing whatever they're doing, however they want to. But I really want to make sure that everyone sees this because first of all, it's really cool. It's really nice to be able to do it the way that we did, but also for understanding it, seeing it when you see it written, understanding what these things mean and not being thrown off by these kinds of details. So any questions about this stuff up to now, what we covered so far with the class? All right, great. So last thing I want to do with this is I want to show, so now we've done, and we have this entry point here in our classes. That's probably not how we're going to run our application. So when we talked about running things by standard kind of in our console, we'll reference a main file. So we're going to do that here too. We don't want to have all this stuff inside of this entry point. We want to have it inside of our main file inside of that entry point. So what I'm going to do is I'm going to cut this stuff out outside of this entry point. I'm actually just going to get rid of this entirely. So the only thing I'm going to have in this classes.py is our definition of a car class, and that's it. No instantiation, nothing. I'm going to take all that instantiation out, and I'm going to move it over here to our main.py file. And I'm just going to drop it inside of our entry point here. So I just cut it out of the classes, and I paste it here. So it's the exact same stuff. And when I save this, you should give me a warning that says, I don't know what this is. So it did the same stuff as reading top to bottom, and that definition isn't in here. So in Python, the way that we get things from other places to come in here is with what's called an import statement. Import statements are massively important. So we use these in Python to get things to where we want them to be and make our applications complex with a whole bunch of different files, but can run it from one file. So what we're going to do is we're going to import our classes from that place, and then we're going to be able to use those classes here. So we're going to say, sorry, not import by itself. Import by itself is when there's like a package that's built into Python. When you're doing it in, inside of your own projects, you want to start with from, and then you have to say from where are you getting this in? So I believe, and I didn't write notes on this, I believe it's just classes. We might have to put a dot in front of it. We'll find out here in a second. You say, from where are you pulling this thing in? And then what are you doing? We're going to import. And then we're going to import the name of that model, or not model, class that we want to use, car class. And so now, save it. That got rid of our thing. So I think my import statement is good because it got rid of our little warning over here on the side that said it didn't know what this was. So now it does know what this is. So again, doing this sequential control structure like we did before, the interpreter is going to read this and say from classes import car. So it's going to go over to our classes.py, and it's going to read this definition of car, check it out, say, okay, cool, I got the definition. It's going to come back to main.py and say, great, I got car. It's going to read all these definitions and say, okay, cool. And once it gets down here, it's going to say, all right, you want me to instantiate a car with these keyword arguments, and you want me to display my details. That's what I'll do. All right, so now when I save this, if I go run it from one of my consoles, which just going to close this Python console because we don't need it. You can leave it open if you want to. When you go back to my bash console, and I'm going to run this in the same way that we have, except I'm not going to run the classes.py. That won't work anymore. So I'll show you that. If I try to run classes.py, nothing happens because we don't have any entry point there anymore. We remove that entry point. So now we're going to be running this on 3 out of our main. And there we are. Voila. So we have all the things from the class. It runs exactly like it did before, except now it's running from our main files. So this is a way to keep our definitions of classes in one separate place, and then our functional code that runs and the entry point and all that in a different place. Any questions on that?
Would this be kind of like a real world use case in terms of like, I guess, if within an application there's a module,
Yep.
and then within that module it allows people to do certain things, this would be like an API call
Yes.
to basically reference to a different feature within that
Yes.
function?
Very
Okay.
much so. Exactly what this is. So this is a real world structure of what a Python application will be. And when we start building our application next week, which we are going to start doing next week and laying the foundation, it will be in Python, but it'll be using a framework called Django. And it's quite literally this. It's going to be an entry point into that application. And then there's going to be a whole mess of directories and files, and there's going to be like a whole ton of them. And we're going to keep adding more to it. And just like you said, there's different modules that we use. You can import, you can write your own, you could use ones that are already made. But this is how we do it, is with import statements and entry points. It's going to be a lot of these same patterns. We're not going to be writing these so much anymore after today, but we're going to be using it. So this is how those things are going to function, and this is exactly what that is. So yeah, good call.
Another keyword I've come across is extends.
Yeah, extends. So
what's the difference between the importing something and extending something? Is it like you're taking the base and just, I'm going to give it another function that it doesn't have today, but I need it for my app, so I'm just going to add a new method to the string class that will do this weird thing with a string that nobody needs but me?
Kind of. But so extends in the context of Django and Python that we're going to be using next week and moving forward is when we get to the front end templates. And what it's going to do is you're going to write a base template, and then you're going to say extends, and it's going to like take that base template and then write another page, right? So all these sorts of things that you have a
right.
banner across the top of the page and it's always there. Of course, when I start saying that, this site doesn't have that. But
No.
any of these other sites
I
that have
remember,
like all this stuff up here on the top, yeah, it'll extend the base
HTML
format. So that's a Django specific thing. It's not like Python imports, but it's kind of somewhat similar. So I see the confusion, but we'll get to that. We'll get to that more later. Good question. Any other questions? All right. So we got about 5 minutes left. So I'm not going to go through an example of working through an algorithmic problem, which is okay. That's totally fine. We can maybe spend some time doing that next time, because we are going to talk a lot more next time on Thursday. We're going to talk a lot more about algorithms, how you choose them, what you do with them. So we could go through solving algorithmic problems. But I do in the last 5 minutes want to kind of show you the tools that are available and send you out that set after class so you could practice through them and show you like what there are and what's available. Stephen Jones, I see your question in there. If you want to hang out after class, I can help you maybe with screen setup. That's a little tricky to do remotely if I'm not next to you, but we could try. I see your question in chat, and I'll get to you after this. Let me get through this last 5 minutes of stuff, and then I'll be with you. Does that work, Stephen?
Sure. Great. Thanks.
Cool. Yeah, no worries. Yeah, and absolutely. That's wait, you have a question, Cody, about Django?
No, that was for the class.
Okay. Yeah. We are using that to build our web application. We'll talk a lot more about Django. We're going to be living in it and dissecting it very deeply. It is a Python. So it's a framework. It's what's called a framework, but it's written in Python. So if you read Python and understand it, you can use Django. It's made for web applications, so it's specifically for web stuff. But we'll talk a lot more about that next week and what it is. Right now, what I want to show you is in the free coding resources, there are a couple of things included that will give you really, really, really good practice on using the control structures that we talked about, building logic and writing algorithms. They're called Code Wars and Leet Code. These are two amazing sites, both recommended to me by people who are professional developers. Code Wars is really an accessible kind of for beginners, easier place to start. So we put together a list of problems, about 20 problems that we'd like you to work through as at again your own pace. And these are beginner level. They're mostly not mathematical, but this is a place where you may run into math being something that you would like to use. But these are mostly focused on strings and lists and the stuff that we've talked about, basic logic and functions and stuff like that. Leet code tends to be more professional focused. Like both of these are getting you ready for coding interviews. It's good to know even if you're not getting ready for coding interviews. But if your goal is to be a developer, this is the kind of stuff. These sites are where you need to be and where you need to be living. So the way they look, both of them are formatted roughly the same. So I want to give you a quick orientation on this and encourage you to go and do these things because they're a lot of fun. And what you're going to do is write algorithms, and you're going to practice this. So when you go to Code Wars, what you're going to do is you find a problem that you want to do, and if you go off the list that we gave you, you just click one of these links. It'll take you specifically to one of these problems. But it'll look like this. It'll have the name up at the top where it says generally the name of the problem. It's usually kind of explanatory. But the actual problem itself is down here in the instructions. Now, this one that has an example, if we had the time, we could have walked through together. Again, we might do this next time. But it'll say exactly what to do. So this one says write a function that when given a URL as a string, parses out just the domain name and returns it as a string. So this is telling you what the inputs are going to be, what the outputs are supposed to be, and what your algorithm is supposed to do. And that's it. So you take this and you come up with your plan, and then you write your algorithm. And then it has a built-in set of tests down here at the bottom that if you click this test button, it'll run whatever code you wrote and it'll run it against these tests. Now we don't need to worry about all the code that's in here. You've seen some of this already, so you generally know what's happening. Here's our import statements we just talked about. So there's some things being imported. Here's our, don't worry about these little at decorators and some fancy stuff. Not important. But here's a definition and there's, some things happening. The main thing that we want to take away from here though is down here in this assert equals. You're going to have this first part, which is the input. So this is the known input, and this is the expected output. So again, our function in this particular one is trying to get our, see if I can zoom in a little bit so it's easier to see. So we're trying to get our domain name. So in this case, the input would be http://google.com, and we want the output to be just Google, right? So this is really valuable to know, again, to see what it is that you're expected to do. But I recommend you come in here, you just run test. Hit this test button first, and it'll run it against your tests over here. You see it says output, and it'll say how many you passed, and say how long it took in milliseconds to run. It'll say how many of the tests you passed, how many you failed, and then it'll give you some information. So this is the actual outcome. Since we didn't write any code, it gave us nothing. So our actual outcome was none, but it said what the expected outcome was. So down here again, just like in our test case. So what we're going to do with these is generally speaking, what you want to do is go to the instructions and start coming up with a plan. Like, what would you do to get down to this answer and write some code that does it? And since we don't have time to show this an example, we can do an even simpler one. So multiply. This is a very, very simple one. I even have an answer in here still. But the best thing about these is once you figure out how to solve one, and once you write an answer in ready code, so this is a much simpler one. It says something that multiplies two numbers together. You all should be able to do that very quickly. But once you've solved one, you can go down here. It says view solutions. And this is the best part of the training tool by far, is once you've solved it, you could see other people's solutions. So here's one of the top solutions to this problem that I just showed you. It's not a solution that, like, if we walk through this together, I would not have written this. I am not this clever. Mine took like 15, 20 lines or something like that. This is one line. So I do have the answers to all these algorithm problems that we're going to send you out, but I encourage you to try to solve it yourself and then look at other people's solutions. And it'll stack it up against your own. You can say, compare with your solution on here. Take some of these, make sure you read and understand these, because these are all viable solutions. These all worked. They'll work at different speeds. Some are easier to read for a human, but you see there's tons of different approaches. And this one I think was probably being kind of a smart ass, because look how explicit that is. But all kinds of ways to solve the problems. Great tools. I highly recommend you getting in here and doing these. The goal, if you are, again, going to be a professional developer, is to be able to solve these types of problems that are on these lists in about 45-ish minutes, including the difficult ones. Now, that you don't want to be spending much more time on that. But if you're not there right away, like when I first started doing this, it took me forever. It was taking me like a day or two to do some of these. So don't beat yourself up if you're really slow at them, if you're not really good at solving the puzzles right away. Put in the practice though, put in this work and try these things out. Any question? We're right at time. So do we have any general questions with any of that before we wrap for the day?
The link to that Google Doc, are you going to send that out or in the email or?
So it is pinned in the Discord server on resources. I emailed it out the first day on break, and I can email it out again as a reminder. I'm sorry, this algorithmic problem solving, you mean?
Yeah, that one.
I'm sorry. Yeah, this one I'll email out. Yes. I'm sorry.
Okay.
I thought you were talking about the I was looking at this page, the resources that I sent out already. Yeah, I'm sorry, dude. Yeah. Algorithms I'll send out at the end of the day. I wanted to make sure that these were still good. But yes, I'll send this out with the video. And then again, I have solutions to these. Some of them are my solutions, so they're not the best solutions. But if you get really stuck somewhere, hit me up and I'll let you and I'll slide you the solution for it. But try them yourself first. I don't want to give you solutions and the problems all at once. But yeah, I'll send this out after class.
Okay, cool. Thanks.
Yeah.
Sorry,
Yeah,
I
sure.
keep forgetting about the Discord.
Yeah, man. I'll pin this in there as well, which I'll answer you like a smartass like it's in there and it's not. So any other questions, logistical or otherwise? Questions about classes or all right, cool. So I'm gonna stop sharing my screen. We can wrap up there. Thank you all for coming, for participation. If you have anything else that comes to mind, questions, reach out on Discord, email, smoke signal, whatever you got. And we will see you Thursday.
Thanks, Jeff.
Yep.
Thanks, guys.
Thank you, Jeff.
Have a good one. Bye-bye.
Yep. Wait, Steve, you want to hang out and get your...
Yeah.
Okay, cool. I will stop the recording.